authentication screen comes up. So right now, we have configured it so you can integrate any OAuth system to authorize your login in your organization. In states case also, they I mean, they have an option to integrate with any of the systems that support OAuth, right? So this is right now configured it to GitHub Teams. So the moment you hit the URL, it is asking for to authorize through GitHub. This is how we have configured right now. So you should have a GitHub account, and the moment you authorize, this is one time. So once you do it for that entire URL, it will not ask for monitoring, tracing, and stuff like that, right? So ensure that you have a GitHub account, like PRK or somebody, like if in case you want to visualize any states, this one, right? So you should have a GitHub account. So once you say authorize, so it should, take you to the, Grafana. So Grafana is what we use for, monitoring. So these are the two dashboards that we have put right now. So first is the cluster overview. So this kind of gives you an overall view about your infrastructure, what's happening, and how the load is, and how each services are running inside the pods, and what are their memory, CPU utilizations, and stuff like that. So let's delve a little deeper into it. So this is what you will see. So here you have various options, like you can go look at the node level. Most probably you won't be doing this rather what you would be. So I'll just go one by one. So the overall cluster, right? So it gives you like how many, what is the age of it, and how many total parts, and what are their memory and CPU utilizations and stuff like that. And the other key stuff is here. So the Kafka consumer group. So this is like little critical from a delivery standpoint, because if at all there are I mean, being a asynchronous system, right? So most often we just perform transactions, and we get a notification it is done. But actually, it gets into the Kafka queue, and then it gets persisted. So in the path, somewhere it can go wrong. So those, those are some of the lags which you may not be able to, figure out easily, right? So this is, we have created these metrics to, dashboard it in under Kafka consumer group. So here is where you can see the lags. So if at all, there are a number of topics that are supposed to be persisted, but not persisted yet. So those are some of the topics which you should be able to see it here. And once you see the lag, you can actually, trace back into other, you can go to Jaeger, you can trace like, what's happening in the journey of the transaction and stuff like that. We'll look at that in a while. So this is overall cluster status and Kafka consumer group and persistent volume. So we use a lot of data persistent, the persistent volumes for our Kafka, Elasticsearch, and both like Elasticsearch product as well as infra persistent volumes. So sometimes they go exhausted with the disk space. So here is where you can also monitor that. So that becomes, so sometimes you see Elasticsearch is not working, or you're not seeing the data in the Kibana, right? So those are some of the cases where you will refer whether the persistent volumes are full and stuff like that. And also you should be able to dig deeper at the namespace level. So here we have different namespaces. From a product point of view, you would be more interested in eGov. Here is where all our services are deployed, right? So this gives a holistic view on like the various services, how many different replicas are there, how they are consuming about the CPU, memory, and stuff like that, and the relevant graphs also plotted here, right? So in case you want to go deeper, so you should be able to dive deeper and understand, like, which time frame it has happened, and you want to kind of look at the historic data about like 24 hours, 2 hour, 2 days, 7 days. So all those possibilities are here. And yeah, so this is more of a dashboard that you would refer from a infra point of view, the cluster point of view, right? And there is another dashboard called Ingress controller dashboard. Here is where you will actually monitor the live traffic. So how many requests are coming, and what are the success rate, and which of the services are being called most often, and things like that. So as you can see here, like the first panel shows that controller request volume, that is 35 operations per second, right? And total number of connections, what is the success rate, 99.54%, right? And also at the various individual service level also, you can see the latency dashboard as well. So what it shows here is, like, it also gives you see, for example, TL service. So instead of looking at as a plotting it as a the overall average, so it is clearly bifurcated as like percentile, 50% latency, 90% latency, and 99% latency. So it says, like, TL calculator, 50% latency was like 35 milliseconds, and 90% of the time it is observed that 130 milliseconds, and 99% latency is seen like 450 milliseconds. So this is how you should understand this. And also several other details, like the network pressure, average memory utilization across various services, across CPU utilization, and stuff like that. So you should be able to dive deeper. You should be able to sort out, like, which is actually showing more latencies and stuff like that. So when you actually, how you actually debug, how do you actually, what it translate into, or how do you actually approach towards troubleshooting, right? So for example, ego searcher is showing some latency, right? So what you can actually do, you can actually go back to tracing and actually look at, like, why this searcher, ego searcher, is taking time. So for that, you need to get into another dashboard. So it is similar, whatever the URL, just put the tracing, and you should be able to get this dashboard, which is nothing but a Jaeger dashboard. So Jaeger is what the tool that we use to trace the services. So for example, whatever the eGov searcher, right? You need to key in the, you can select from the drop down, and there are several options, like you should be able to get all, or stuff like that. And if you specifically want to see if there are any errors in eGov searcher, so you can always say that error equal to true, show me only those transactions which has got error, right? So you should be able to do this. Let me hit it. And
Gajendran, you have a spelling error for true.
okay, thanks. Anyway, so it means that there is no error in the recent transaction on ego searcher. So okay, so other,
You can try with workflow service in case you want to show.
yeah, yeah, I'll come back to that example later. Let me cover this other things also, like if you want to observe that how many durations, what is the minimum duration that you want to set, like, so for example, like I want to see the service I mean, I want to see those transactions which eGov searcher took, more than like 10 milliseconds or seconds or things like that. You should be able to key in. So for example, I can put 20 seconds. Uh, I mean, minimum duration is 10 seconds. Max duration, it took about like whatever 60 seconds. Or you can, just monitor those transactions that took more than 60 seconds, right? So you should be able to, just find the cases. As you can see here, like, yeah, it just gives you the transactions that has taken, uh, matching your criteria, and you should be able to actually drill deeper. So clicking on it, it also gives you like what exactly has happened, and you should be able to see whatever the transactions have happened and the respective logs and stuff like that, right? And another you know uh, important feature, it also gives you a graph, like you should be able to, depending upon your last 1 hour, or like if you want to see some you know custom duration, even that, so it should be able to plot that graph for you, so that you can understand, okay, during this 10 to 10:30 time frame, something has happened. So similarly, you can trace back. So how do you trace back other services, like maybe the dependent services on eGov Searcher? You should be able to actually click on this deep dependency graph. So yeah, so this can, so it can also give you like how, what are the dependent services, um, I mean, eGov Searcher, how what are the other dependent services? I'll take workflow as another example.
Within the try from the other
Uh,
Then you are
or
doing
I
it in
have it.
UAT instead. Go to prod V2 one tracing.
mm, me too.
I have it open.
Yeah,
Shall I
yeah,
present?
yeah. Please do.
Right. Right. So, like Gajendran was saying, you can get all the errors, all the spans that are, all the requests that have just errored out. Right here, you can see there are several requests that have actually taken over 100 seconds or over 60 seconds. Right, and you can also see at what points of time this has been happening. Okay, and also you can deep dive into and analyze as to where exactly this slowdown is happening, because you can see because we are in a distributed microservices system, the queries are not always going to one pod. They're going to split into multiple pods. Multiple queries are happening to database and all of that. Right, so here you can see the entire request till here is progressing quite normally, but then once it comes to this query, it's taking 71 seconds. So debugging now is much more easier, because you now know what is the exact point which is causing that delay, right? And then you can just focus on this. Now without this, you would then have to probably try and figure out what is happening in this entire system, which call, which service is actually causing this problem. But here, it's going to be much more easier for you to find out. Now the other thing that you can do is, imagine you do a search here, right? So Every search gives a response called the correlation ID. This is what we said, and you can always use that here. So this is the correlation ID for the request that we made. So now the powerfulness, you can see this right now as well, because you just made any request. If the client or anyone, right, from the front end can submit this correlation ID, say this request took more time, so I'll submit to the analysis, maybe a queue, and then you can do the analysis by this. So once you have the correlation ID, you can now figure out this request, what all paths it took to know to return in the time that it did, right? 347 milliseconds, right? So if you see this, and the actual transfers are 263, so you can see that the exact amount, why it took this much time, right? You can actually get the detailed report of that. And your optimization of the queries become much simpler now. I'll think it's a good time to take a pause in case anyone has any questions in between. If not, we can keep going.
So Nitin, one thing, this lags that we were showcasing, what is the refresh rate on these lags?
Right. So these are all controllable defaults, right? As of now, it will be per environment basis. By default on dev and QA, it's going to be 2 minutes. So these dashboards are actually going to reflect 2 minutes. On production system, you can have it much slower, because there is a compromise that we have to do based on how much CPU, memory, and data are you going to allocate for your monitoring and tracing dashboards, right? On dev and QA, for instance, we cannot expand to collect metrics much more frequently, so we do it less frequently. Now in production setups, you can always configure in that particular file saying collect the metrics and refresh them every 5 seconds or every 30 seconds. Okay, so that is a configuration that you can always control.
And how long are we storing these metrics?
These are stored for 2 days by default. Again, this is again a configurable option. If you, for some reason, you want for a different environment, you want to collect for longer, you can do that. Now, this is for the monitoring. The tracing dashboards, the data here, because this is much lesser, easier to store, less memory intensive and stuff. We store these for 14 days, and the logs are stored for 7 days. All three are configurable.
Okay, so these are all troubleshooting tools and things like that. But is there any way we can find the number of concurrent users on the system and concurrency at a service level?
So concurrency, I think there are a couple of things. Now, user itself, if it becomes a business question, right? If you are asking as how many logged in users or registered users, that has to come from telemetry. But if we are talking as to how many concurrent connections or requests are happening at the entire cluster, this you can take that as this one. Like 65 operations per second is what we are hitting right now.
This is at a Kubernetes level.
Yeah, this is the entry point to the cluster. So any request, right? Even the UI, anybody making a call to our server, whether the UI or the API or anything, that is 62 operations are being made per this thing. If you want it at service level, we have this one. So you can see that localization is 12.98 requests per second. MDM
Right.
23.19 requests per second. At the same time, if we increase the collection speed, collection timing, now we are collecting probably at 60 seconds. So if you want the real time update, like every 5 seconds, what is the update, or every 30 seconds live update. So we need to alter this and redeploy it so that it reflects that, okay, give me metrics every 30 seconds as to what is the current data being collected, like how many requests we are hitting right now.
Understood. Obviously, if you make it more frequent, it'll have a significant hit on our compute and storage and memory and all of that.
Yeah.
What's
So,
the recommended optimum frequency for this?
so there is actually a document that we published. I can pull that up. I can send that out in the post meeting. So the default as of now in dev and QA, we are saying we'll sample every 2 seconds. I'm speaking about the monitoring and not the tracing and logging. The monitoring dashboard every 2 seconds is what we'll be pulling. Every 2 minutes, right? And then in production setups, it's best you go for around 30 seconds at least. And if you're doing debugging, you can go even more lesser as well, less than 15 seconds.
Okay. And is this deployed in Punjab?
It's deployed everywhere.
Okay. Punjab, Uttarakhand, it's deployed. Whatever we are managing.
Yeah, yeah. So I think, I mean, on a day-to-day basis, these things are being used for debugging, especially the trading dashboards and stuff, right? They're being used on a everyday basis to figure out the issues that they have.
So there's no limitation on having to be a public cloud deployed infrastructure. If it's SDC or NIC, also we can deploy these services.
Yes, yes. So there is one restriction to this, because some NIC, like for instance, on NIC public cloud Kubernetes, right? They don't give access to the cluster wide. So in that case, we cannot do our logging, right? In that case, we can only do things like Jaeger and monitoring, because they provide their own systems for doing this.
Okay.
But any other Kubernetes cluster we deploy, normally any cluster that we do, let's say Bihar and Uttarakhand, where we have the cluster access, we can deploy these things, and they are deployed as of now as well.
So Chandra, just to add to it, like see these monitoring, tracing, all of it are nothing different from our ego services. So these are some of the add-on services that we are giving for operations and infra monitoring and stuff like that. So they can be choosy about what they want. If they don't want to use ours, they can always go with theirs. But we always recommend using it because it's all pre-configured and everything is ready for our environment. But if in NIC, they have central dashboards. So if they choose to not to go with this and to rely on that, so they can always go with that. Whatever the customization needs to be done, we should do it internally. So that's it.
Ganjan, I have a couple of questions. So is it going to be some by default some config available as part of product packaging itself when we deploy?
Yes. So all you need to do is like, you don't need to do too many configurations and stuff like that. We have already published the document saying, okay, these are the defaults, like, like Nitin mentioned. So these are the default intervals in which we are collecting the samples and also retaining it for these many days. So on top of it, if at all you want it, so here is how you will actually go customize it or configure it and things like that. So just like how we deploy PG service, right? You should be able to deploy even monitoring, and it's up and running. You don't need to do any special things. So if at all you choose to, I mean, not to go with this because of some hardware constraint, or you have a budget of reducing the cost, maybe you can opt out. But nevertheless, for implementing all like monitoring, logging, tracing, so we have done enough work to keep it like very optimized and very low on the cost as well.
Is it this can still be deployed in the same VM, right? It doesn't need to have a separate infra or a separate VM.
Nothing. So as I mentioned, so in every cluster, so this will be just like another eGov service.
Okay. Okay.
No, you'll need some more compute, yeah. You will need little more compute, but not like
So
or
the
chat.
QA package version that is running, right? The monitoring and the logging and the tracing, they would require, I mean, excluding the Elasticsearch dependency, which is anyways required for other, we can reutilize that. Excluding that, the CPU and the memory is around 2 to 2.5 GB is what this part is using for the entire stack of the monitoring, logging, and tracing. Of
Okay.
course, this will increase as in case you want to collect metrics more frequently, you want to run more the dashboards, you want to refresh them more frequently, which means these queries that crunch those and show you the visuals, right? The queries have to run much more on larger data set, and they have to run more frequently, which means that at that point of time, we might have to increase the memory and CPU accordingly.
So these queries are running off Elasticsearch, is it?
So this one, Jaeger runs off Elasticsearch. This itself has its own PromQL, so it's just a single deployment, and then it maintains its own small data source inside.
And you're saying the total size right now is about 2.5 gigs,
Yeah, for the entire thing. Yeah.
including Elasticsearch.
No, Elasticsearch is not included. So Elasticsearch is reutilized for different things. So for Dev and QA, we don't deploy a separate Elasticsearch for this. We utilize the same thing that we use for the business as well. right? So I'm not counting the data required for that. Now, if you're counting that, that's going to be a little more higher.
Okay.
Okay, one quick question. Tarun, I hope we have utilized this for our analysis on the simulation. Any findings you want to highlight?
Yeah, Raju. So for our performance test, Jaeger we have been using. So you might see some extra logs on the user side because we specifically added some span for debugging our performance issues, and a lot of otherwise on any service there is nothing for inter-service call for the DB calls. There is nothing in the code that anyone writes, and all the services directly go to this Jaeger without us writing any code. And this has been one thing that this is our go-to thing to actually see where if a call is taking time during performance test, where it is going wrong.
Okay, okay, okay.
And Chandar, to your point, what you were asking for monitoring, what you were asking is more at an application level. These two things are more at an infra level where they may not worry too much about application level details, which are, let's say, which URL and all that.
Okay.
So
where
for
are
that
we sorry,
for
where
that
are
also we have added one more dashboard in Kibana.
so application logs, exceptions, and all of that will get logged elsewhere?
So you can see that right now on the screen. So this is where you will see. So there are from the past 12 hours, there are about 14,740 errors that have occurred. So these are logged out errors. Reasons could be false positives as well. But then, yeah, I mean, these are the errors that are being put out by the services itself. You can also see how frequently these are happening and by time, how are they increasing and stuff as well.
Right.
So Nitin, let me present one thing. Just give me a second.
And these logs for the application, these are all coming from our basic logging framework that we have.
Yeah, so let me just highlight in this one. So both the logging part and the tracer part, right? There's a small amount of instrumentation that's required in each of the application. But we didn't want to touch the code of the application to add this because refactoring will be difficult. But instead, what we do is to every Java app, there's a dependency library that we add. In that library, we add a small amount of code which does that thing.
Got it.
So Chandar, you are able to see this screen?
Yes, yes.
Yeah. So see, this is what we have now, as Nitin mentioned, we reuse most of our Elasticsearch and Kibana. So this is a new dashboard that we added this Tuesday for monitoring our performance simulation runs, where you can see that how many different tenants have logged in, how many total employees have logged in, how many citizens are currently active on the portal, and this is not current active, but during that duration that we have selected. So that day the simulation run was between 3 to 420. So between 3 to 420, you can see that in total 123 tenants came in. There were almost 60,000 API calls, and we could see that half of that was almost MDMS calls that are happening. So this dashboard now gives us a good view in terms of when we are doing our performance testing, what is the kind of load or kind of ratios of load we want to present to different services when doing our performance testing.
Surprisingly, localization is fairly low.
That is because see, if you look at user, there are 5,000 user calls and there are 5,000 localization calls. So when somebody logins, most of the times the localization will get called if it is not already cached.
Okay.
So that's the reason the number of calls would always be similar to user.
Okay, so this is
And then you can even look at which particular API, how many errors had happened. And for every error, the good part is that we capture the error response. So we do not capture any response which was without error. But when an error occurs, we are capturing the response that was also sent. So this gives us idea when we are looking at simulation run, there are certain API errors that the end user might not report, but we can look at every single error that happened during that simulation run or a particular run and see every exception detail.
So Tarun, is there anything on like on the I think first or second day of simulation we noticed, right, the pod restart and all those things? Is there anything proactive alerting for that? So this is monitoring, but from the alerting side, do we have something like that?
So this has nothing to do alerting. Alerting is all in Prometheus. So that I guess Gajendran can cover if we have started considering the alerting or not. But this is more for an active monitoring where you want to monitor how many number of API calls are happening.
But
For error and
yeah,
all, it has to be Prometheus.
Yeah, so we'll cover that, DJ. So far, like, let me quickly recap, right? So since we are jumping into too many things, so we have looked at the monitoring. So that gives, the cluster level and at the, the overall traffic level, and then tracing we have seen. That is where you go deep dive into each service, like what are the errors and how is the journey of different calls are happening, where is the bottleneck and things like that. And then we have also seen the logging dashboard, right? So here, so now the data is available in Elasticsearch, so in Kibana, right? So whatever the you should be able to create even more dashboards like the one which Tarun was showing. So you should be able to create those dashboards depending upon your requirement and the needs, but the data is present, right? So that is another capability that you can leverage. So now the final flavor of this entire observability stack is what? Alerting, right? So alerting is like, we have configured it to different Slack channels. So we have created groups for like, production, Punjab production, Uttarakhand production, and things like that. So here is where, you should be getting the various alerts, like, if the cluster is running out of CPU or memory, the entire cluster, you will get a notification. If any persistent volume of the backbone is going down, it will alert you. If a particular service is like waiting for a long time, you have deployed, but you have no idea that whether it is running or not. Even for those, like, it will keep saying, it is in a waiting state for a longer. So as Nitin is showing, you can see all those alerts here. So and these alerts are not restricted at only to these things. And as you come over, and if at all you want to configure the alerts, you should always be able to do it. And on the other hand, if at all you want to suppress certain type of alerts, so you should always be able to go to alerting dashboard, and you should be able to silence it as well. So maybe you see a pattern that this is not kind of more it's not giving any relevance to take any action. You should be able to, again, just URL, just type alerting. So yeah, you should be able to see these dashboards. So yeah, take over, Nitin.
No, it's okay. I think, that's about it. So, to answer the question, there are plenty of alerts configured. Now, again, here also, what is the uh, uh, thing is, how frequently do you alert, right? Do you wait for, now if you're collecting these metrics every 5 minutes, then you can only alert if this is happening for the 5 minutes or 15 minutes if the restart is happening. Now, this is again depending on how often we collect the metrics, right? These kind sort of metrics usually are corrected quite delayed, because for a dev and QA setup, we don't need them to be collected very often. This can again be tweaked on, let's say, a production system where you want to collect and report or alert on these metrics much more frequently. Like immediately a pod goes down and it's in a crash loop back off, you get a report, right? Or the alert itself. So you can start collecting metrics more often. The trade-off is the same. Once you start collecting metrics more often and want to alert more often, your CPU and memory that you allocate will again be increasing by a slight amount.
So, any more questions?
Nothing. I think just a quick time check, Satish.
Yeah, I think so. I think we can cover one more topic today. I think two more we can push it to the next week, maybe sometime. So yeah. So if there are no questions, I think.
Okay.
Thanks,
So
Gajan.
yeah.
Go
So
ahead.
yeah. So before we close this discussion, right? So see, the capabilities are put out an end to end. So now that as we start using it more often for our internal testing as well as monitoring the production system from a delivery standpoint, right? So that is when we keep collecting a lot of feedback. So this is there right now from a very standard way. Like for example, we are saying we have configured all, like considering dev, this is the sample collections and the whatever the durations that we collect. In production, this is what it is, and what would be the impact on the infra. So we don't have that enough feedback yet, but we have considered based on our analysis and some of the standards. So we have taken certain durations for collecting samplings and also retaining data. So as you start using it on a day-to-day basis, so we would be getting more, keep giving more feedbacks, and we should be able to do the course corrections or like come up with more metrics and stuff like that. But so whatever we have put out right now, so this itself is like a exhaustive, kind of thing to look at, the troubleshooting as a whole from an end-to-end perspective, right? You look at logs, you trace it, you see the traffic, you see the infra, everything is just there. So you need to start using it and give feedback so that we keep reinventing, or like we keep working on this. It's a journey, right? So we keep doing improvements and we keep releasing it. So the feedbacks would be more helpful to actually add more stuffs to it. Yeah. Thanks. Hope this was useful. Yeah.
Yeah, thanks, Gajendra, Nitin, and Tarun. I think the monitoring, logging, and tracing, it is